Remember that in the lecture, we talk about diffusion. Diffusion is how the molecules from one place, they will be able to move over to another place based on the concentration difference. And they need to act through some sort of like a medium. Now, we want to do a demonstration and tell you how the medium, whether the temperature is high or low, or whether its viscosity is high or low, is going to affect the diffusion rate. So we do this by the following setting. On your left-hand side, we have a glass of water, which is of room temperature, relatively cold. The other side, you'll still see the steam coming out of it. It is a glass of hot water, temperature roughly around like maybe 80, 90 degrees. So we're going to put in some dye and ask how long does it take for the dye to diffuse throughout the entire glass of water. So let's take a look at it. This is the hot water, and this is the cold water. Let's pay attention to it and see actually how fast they become totally homogenized to have the red color fully distributed in the entire glass. You may notice that on the left-hand side where the water is cold, sometimes you find that the dye, they are stagnant, they're not moving at all. Based on the very slow Brownian movement, they are simply moving a little bit, but then they're not really mixed very well. But if you look at the right-hand side, you may recognize that you can't see the dye at all. Basically, they are almost like a mix-up in a homogenized solution form. So what it tells you is that on the right-hand side, because of the high temperature, in fact, the dye molecule, they will be able to move around very effectively, and so therefore they diffuse very well. But on the left-hand side, you find that in cold water at low temperature, diffusion occurs much, much more slowly. In the second experiment, we're trying to demonstrate the effect of viscosity. Essentially, the experiment is identical, but let's look at what we do. We have two glasses in front of us again. On the right-hand side, we're going to put in some starch solution. They are much more viscous. Here it goes. You say that they're a little bit turbid. Okay, done. And on the left-hand side, we're going to put in water. This is just tap water. So basically, in terms of viscosity, they are not as viscous. So we do the same experiment again. Now what we do is that we're going to put in 1 drop of the dye. Let's look at it. 1 drop. And let's look at it. 1 drop. Now, clearly, you can see the difference. On the left-hand side is just the water with relatively low viscosity. And you'll find that the dye start to move around a little bit as effectively as what you saw a moment ago. But if you look at your right-hand side, look at what happened. So this is a very viscous starch solution. And you'll find that the dye is on the top. It is not moving at all. Basically, they have a hard time diffusing over distance. Let me remind you, in fact, diffusion still occurs, but it's much, much more slowly. If we stay here for long enough, you'll find that the dye would start go into the solution. But then it will never be at the rate as fast as the one in the water. So combine both together, basically it tells you the same concept again. High temperature with a very high rate of diffusion, high viscosity, they block diffusion very effectively. So in the future, when you're cooking something and you want to have certain dye being mixed up with the food, think about the viscosity and the temperature. The same thing when you're thinking about aroma, how something smells. If you have a medium which is of low viscosity, actually they would be able to diffuse much faster. And also you can increase the temperature by heating up a little bit. They always smell better.